I'm Folefak Martins. I'm lead instructor at Neuralearn.ai and also co-founder at Binside Technologies. In this presentation, I'll be talking about a practical approach to learning deep learning for computer vision. So for any one of you who have maybe say some little experience with deep learning and computer vision, this talk goes for you. We recently launched a course on deep learning for computer vision, which we made available for free on Free Code Camp. You could go check that out. And in this course, we are going to be using tools like Hugging Face, TensorFlow, 1DB, Albumentations, just to name a few, to help you in solving your different problems. Now, that said, the prerequisites for this course are actually intermediate Python knowledge and basically no math. So you could see from this comment right here where one learner says, hi, are there any specific math prerequisites for this course? And another learner response is, I have completed till 5 hours and there was no need for math till now. Well, for this prerequisite, there's a need for math, but there is no need to like have gone through all these different courses before you start this course. And so because this is actually treated in the course, any math you'll be needed or you'll be needing, you would actually get it explained in the course. So that said, the way we structure this course is such that from the beginning, you understand that this deep learning you're trying to make use of, the context of computer vision, is there for you to solve a problem or to solve different problems. So the first thing you have to do is, as you want to learn or as you want to upskill with deep learning for computer vision, you have to start with a problem you really want to solve. So that's how we structure this course. Essentially, we just have a series of problems we want to solve. We solve them, and then we show you how to do this much more efficiently. So you could see, for example, here that one problem or a problem which we could solve is that of taking in as inputs X-ray images like this one, and then having to output this kinds of, or better still, having to show you where there are abnormalities on this input image and also the type of the abnormality. So this is a problem we want to solve, and then as you go through the course, you learn how to use different tools in solving these problems. Before we start, I want to expose this minimalist ML pipeline. So generally, because deep learning is part of machine learning, ML here stands for machine learning, we want to make you understand from the start that there is this pipeline which you generally want to follow when solving a problem using deep learning or machine learning in general. So that involves data preparation, modeling, training optimization, evaluation testing, and then deployment. So with this minimalist ML pipeline, you would now find that it becomes easier or much more clear for you to, when solving your different machine learning problems. That said, for those of you who are new to the field, suppose that some of the members of this meetup are new, so we'll just briefly explain how deep learning could be used in this specific case of, we could say, actually object detection, because here this abnormalities could be considered to be objects which we want to detect in this input image. So right here, we would have a model which itself is made of millions or sometimes even billions of knobs, like billions of weights. Let the generally called weights, but we could just look at this as knobs which we want to tune such that when we have inputs like the one to the left, like this one to the left, we are able to obtain an output like the one to the right. And so now the way we are going to tune this is by passing in, or the way we're going to get the best weights is by passing in data into our model or by training our model with this data. Now, generally, we deal with millions, hundreds of thousands, and even billions of samples of this kinds of data. You can see from here that we have data coming from two sides. We have inputs and outputs. Now, we wouldn't get into the details like if it's unsupervised, we would just have only inputs, but here we're supposing we have a supervised problem and we have inputs and outputs. So we get this data, we train the model weights, we get model weights such that we're able to take decisions in this case is knowing where we have abnormalities in the input images. So we've talked about this data. We've also talked about the weights, but one thing they have in common is that we have they are just essentially numbers which have been stacked together. So here we have this input image of Abraham Lincoln, which is somehow is pixelated, and you could find that this image could be presented with different numbers. Like this is a 2D or two-dimensional tensor, or matrix as we generally call it. So because we essentially dealing with tensors and variables, we shall start the course with understanding how this works. So you find here that we'll start with the basics of tensors. We'll look at math operations with tensors, linear algebra operations. We'll look at spatial tensors like ragged, sparse, and string tensors. And then we'll look at TensorFlow variables. So once we have this sort of prerequisites understood, we'll then move on to our first project. Remember, when learning, the first thing we want to do is solve a problem. And so our first problem here is going to be a known computer vision problem, actually. And the reason why we do this is because we want you to be able to solve a problem which is very easy or relatively easy compared to the usual computer vision tasks. So here we want to predict car prices using the simple neural network. Now again, you see the role or you see how our ML pipeline comes to play. You have the data preparation, we have the modeling, we have training optimization, we have the evaluation and testing, and then here we're not going to have deployment, but we're going to have this corrective measures section where we'll see that with this ML pipeline, we don't just go data preparation, modeling, training optimization, and evaluation, and then that's it. Generally, what we do is we move up to evaluation, and then based on the results we get in, we are going to get back to, for example, the modeling section and carry out some modifications, or maybe the data preparation section, or even the training and optimization section. So this tells us that it's not just a one-time thing, but you always have to keep updating your system so that you get the best out of it. Now, that said, you could see here to the right this figure which shows you how to create a simple or build a simple artificial neural network with TensorFlow. So it's a 34,000 parameter model, which is created very easily with Keras. So this shows you how easy it is nowadays to build these kinds of systems. And this project actually is there to give you that confidence, so you don't feel all this talks of deep learning for computer vision don't feel overwhelming. That said, we're going to dive into malaria diagnosis project. So now we're going to start with our first computer vision task. And again, we are not going to get into some complicated task. We're going to dive into detecting malaria using cell images like the one to the right. So we're not going to have some, I don't know, images of face of people or some complicated images. We're just going to have something very simple like this, so that you can already start producing results without much effort. So again, we're going to go through our pipeline. So we have here the data preparation section, where we're going to try to first understand the task, prepare the data, visualize the data, and then process our data. we're going to make use of the very popular TensorFlow data API, which will help us, especially in data processing. Then from here, we will get into modeling. So we would understand how and why the convnets work. Now, convnets here, for those who are new to the field of deep learning, stands for convolutional neural network. So you might have heard me say we were building an artificial neural network in the previous section. And in this section, we're now building a convolutional neural network. Now, essentially, here in this how and why section, we are going to be explaining why these convnets are better suited as compared to the artificial neural networks when building our computer vision systems. So here we're going to explain this, and then we're going to build one. So you can see to the right, a simple Lunette model. And that'll be it for the section on modeling. We'll then move on to training optimization. We'll look at a very common loss. That's a binary cross entropy loss. Again, we make much effort to make the math behind this simple. So we try our best to make sure that anyone could understand this. And then we also train the convnets in the section to see in this figure to the right. Again, with TensorFlow, it's quite easy. All you need to do is write binary cross entropy, and that's it. Behind the hood, you have the loss which is used, and then you have a metric which you specify. Then here you have this fit method, which you use to train a model very easily with TensorFlow, Keras. So it's quite easy as compared to if you were to write all this from scratch. That'll be much more complicated. So actually, this is easier as for a learner or for someone who's just starting. It's going to be pretty easy if you stick through the course. Then from here, we'll dive into model evaluation and testing. So we'll understand this concept of model evaluation and testing, because it's one thing to train a model, and it's another thing for that model to perform when and where it needs to perform. So here we're going to look at how to evaluate our models. You see, with one line, we're able to evaluate a model based on a certain metric which we've specified previously. And then we'll also look at loading and saving models to Google Drive so that we do not need to always retrain our models when we've lost our session. So we could always get back to a model which has been trained and then continue training, or we could use that model or we could test that model out. So that's it for this section. Now we'll move to building, or we'll look at how to build more advanced models in TensorFlow. Now, actually, with this Lunette model, if you get back here, you see that's actually these layers which have just been stacked linearly. And so with this type of model to the left, this one we have here, which is just the Keras sequential API, you could have this sequential API and build the kind of build this Lunette model which we're having. But when we have many outputs, many inputs, and we have some complex structures, or we have some residual blocks like the one we have here, you would need some other API. So in this case, you would make use of the functional API. And so that's what we're going to be looking at in this section. So we'll look at how to build these more advanced models with TensorFlow. We'll look at model subclassing, and we'll also look at how to build our own custom layers. So from here, we'll then get into evaluating classification models. Now, we had seen here already that we could evaluate these models, but then there are some we could say evaluation techniques which necessitate us sometimes to actually go under the hood and actually write out what we want. Like, for example, you wouldn't get with a one-liner the ROC plot or a confusion matrix. So you would need to go and write out some code to be able to come up with these kinds of plots. So with this more advanced matrix, we're gonna dive in this section. We're gonna see how to evaluate our models with this advanced metrics. So that's it. Next, we'll look at how to improve the model performance. So when we talk about our models, so far, we've just been building, training, evaluating, but after evaluating, we want to be able to improve this model. So we talked about this briefly with the corrective measures section previously. And right here, we're going to look at how to carry out this corrective measures, or first of all, how to even understand what's going on, especially when it comes to overfeeding and underfeeding. And we're going to be using different tools to mitigate these problems of overfeeding and underfeeding. Now, also in this section, it's true it's not really under model performance, but we just added it here because generally when we're trying to carry out some sort of, or when we're trying to debug, or we're trying to look at some ways the model is performing or behaving during training, we make use of callbacks. So we have this TensorFlow callbacks. We have the learning rate scheduling, which we use during training to modify the learning rate as the number of steps or training steps increase. Then under overfeeding, or under the section on mitigating overfeeding, we're gonna have this section on data augmentation. So we're gonna focus on data augmentation. And the reason why we focus on this is because many times we don't have that much data. So we try to enlarge our data set. And you can see here we have this image of this cat, which is shown, which is rotated and translated so that we have different versions of this same image, so that your model could see this as different versions or different samples. So this section will be focusing on data augmentation and other more advanced data augmentation strategies. Then we'll also look at Albumentations, which is a library focusing on data augmentation. Now we're going to look at the advanced TensorFlow topics like custom losses and metrics, eager and graph modes, and then custom training loops. So far, we've just been talking about training with this fit method, but now we're going to go under the hood and understand, first of all, what goes on when we call this fit method, and then also make some modifications or somehow write our own fit method. So that's what we're going to be doing in this section, together with the custom losses and metrics. Then we'll dive into the TensorBot integration. Here, TensorBot is this tool which permits us carry out data logging, which permits us view model graphs, which permits us carry out hyperparameter tuning and other visualizations. So we're gonna, in this section, take a deep dive into TensorBot integration with our different projects. Then we'll look at machine learning operations with weights and biases. So weights and biases is a formidable tool which permits you carry out experiment tracking, hyperparameter tuning, dataset versioning, model versioning, just to name a few. Now you should know that they keep adding features, so you could go to weights and biases and then check out new features, because the course which we have on FreeCodeCamp doesn't have the most recent features. So that's it. From here, we'll get into our second project. Now, note that all this while we've been talking about these different parts of the course, we've been dealing with the malaria diagnosis project, and now we're going to move to our next project. Notice how we're going from a much simpler to slightly much difficult projects. We're moving now to the human emotions detection project. And here again, we have our ML pipeline as we go through data preparation, modeling and training, data augmentation. This is a corrective measure. And then we'll look at the TensorFlow records. So once we're done with this part, we'll then move to more modern convolutional neural networks. Again, so far, we've been using the LeNet model, which we had seen previously. And so now we'll look at much more sophisticated models, which permit us produce much better results, like the AlexNet, VGGNet. They're pretty old models, but that's especially the AlexNet, VGG, but they actually, or especially the ResNet. The ResNet is still used to date. So depending on what problem you want to solve, you will like to try out with these different models. But in the course, we are not forcing you to, or we are not emphasizing on a single model. We're just explaining how all these different models work, the advantages, and then we also train our data on this different models. So we train these different models on our data. So you could feel free to test all these models out. We actually code the ResNet from scratch in this section too. So we look at these different models going right up to the efficient net. From here, we have the transfer learning section. Now you see here from this simple Google search that the ResNet 50, which is a variant of the ResNet model, was trained on an NVIDIA M40 GPU, and it took 14 days. So this tells us that not everyone has the resources to train such models, even though as of 2023, ResNet is a pretty small model compared to the likes of the Llama V2s we have today. So in this section, we're going to look at transfer learning, where we'll be able to make use of a model which has already been trained on some general purpose data set, and now fine tune it on our problem specific data set. So if you have some data, or if you have a model which has already been trained on a very large or a much large data set, or as compared to the data set you have at hand, this technique comes very handy. From here, we'll look at understanding the black box. Black box here is simply a ConvNet we've been talking about all through. We've been training these models, we've been getting results, but what goes on under the hood? Like, how do they make these decisions? So in this section, we visualize the intermediate layers to better understand how to carry out these decisions. Then we also have this GradCam method. So this section is meant for you to understand how they actually work. From here, we dive into the transformer, or we dive into the VITs, that's the vision transformers. And the section, we look at a model different from the ConvNets which we've seen so far in this course. Again, our project here is a human emotional detection project. So is the same project, but now with a different model. So you notice that here we specified modeling. So we from here, or previously we were dealing with other sections, but now if you look here, we specified modeling to show that we are only focusing on the model. So the data, the training part, the evaluation section remains intact, but our model now is changed. So we move from the ConvNet into the transformer. And here we'll start with understanding how the vision transformers work. We'll build one from scratch. We'll fine tune a Hugging Face transformer. Now, Hugging Face is this amazing platform, or this amazing startup, which is focused on helping democratize AI for everyone. And so they have hundreds of thousands, or let's say thousands of transformer models, which have already been pre-trained, some pre-trained, some untrained, which you could make use of. And in this case, we're going to make use of a pre-trained VIT. So that's it. So in this section, we fine-tune on pre-trained VIT and get much better results compared to the previous models, which we have seen already. So, and then this last section will be model evaluation with 1DB. So that will be it for that section. We'll now move on to deployment. So this last part, which we haven't talked about so far. So in this deployment section, we'll look at how to convert a TensorFlow model, which is the models we've been working with so far, into an Onnx into the Onnx format. And then we'll try to understand quantization. Then we'll look at how to practically quantize an Onnx model. From here, we'll understand also how APIs work. Then we'll build our own API with FastAPI Python library. Then we'll deploy this API to the cloud, and then we'll load test our API. So this section is meant for showing you how to make use of a model which you've trained already to come up with a solution that anyone could consume around the world. So this section is one which is very important. From here, we'll move to the next project. So so far we've looked at 3 different projects. Now we're going to object detection with the YOLO. But it should be noted that, as we've said already, generally what we want to do is we want to take a model, like for example, the YOLO V8, because the YOLO today is up to the 8th version. Don't know whether there's a 9th version already, but it should be up to YOLO V8 by Ultralytics. What we generally do is, or in practice, what we'll do is we will fine tune this model, which has been pre-trained already on some much large data set and then make use of that pre-trained model on our own specific data set, like in this case, this chest scans. Now, in this course, we are not going to dive in, we're not going to fine-tune, or we're not going to show you how to fine-tune a state-of-the-art model like YOLO V8. We are instead going to show you how to build your own YOLO from scratch. So again, the difficulty level at this point increases a little, but we're going to help you to understand how all this works. So you get to build your own YOLO from scratch. You get to see the importance of data augmentation, as data augmentation, or the inclusion of data augmentation here plays a great role in making our model much more performant. That said, we added a section on image generation, though we have a course on Neuralearn.ai, which is focusing on just image generation with GANs and diffusion models. We decided to just add this here, since it's actually this is computer vision still, but and so we deemed it necessary to include that in this course. So in this section on image generation with GANs, we are going to generate 2 types of images. The first will be digits with the variational autoencoder, and then the other will be faces, like not of this type of quality, but recognizable faces, at least using the GANs. So we're going to understand how the GANs work. We're going to look at the GAN laws and then train our own GANs. So that's the course. The course is 37 hours long. It's actually a beginning, because once you finish this course, you have to start building projects. The most important is not to finish the course. The most important is to do your best to go through the course and then start building projects, because that's the only way, or that's the surest way you could get the skills that you need. So you have projects like image segmentation, object counting, text detection, text recognition, depth estimation, image search engines, post estimation, up to video classification. So this is just an example of different projects you could work on. Then you could also look at how to deploy on the web, that's deploy on the browser, so that you don't need servers. Like previously we saw that we'll learn how to deploy on Heroku, for example. But now you could also check out how to deploy still using the Onnx runtime. And that's one main reason why in this course we have Onnx runtime, is because with Onnx runtime, you're able to easily deploy on the web. So because of this, we decided to convert our models to Onnx format, so that at this level you don't find anything, you find it less difficult to deploy on the web. So deploy on the web, mobile and desktop with Onnx runtime, and then generally ML Ops. So you should check this out. That said, once you're working on your different projects, share as much as you can. The more knowledge you share, as in the course of sharing, you tend to learn better, because as you share, you get to see the points, or you get to cement your knowledge actually. So also try to bite a little more than you can chew. So you are a specific, or you have a given level. Why not say, for example, build something you thought wasn't possible before? Why not do a little bit more than what you've been able to do so far? So try to bite a little bit more than you can chew. Also, deep learning for computer vision specifically today has been made much easier. You have compute, you have platforms like Kaggle, which give free compute, although it's limited. You have Colab, which gives free compute, and then they also have paid programs, but they're not necessarily too expensive. Well, it depends on what you're trying to work on, but for the projects we've listed, you could use even the free compute and work with relatively small models, and then learn as you go. So while learning, you could make use of this free compute platforms we have today. We have data sets on platforms like Kaggle. You have Papers with Code, which also comes with data sets. You have dataset curation platforms like Voxel 51, which is an amazing platform. You could check that out as you learn. And then you have models which are much more easier to find today. Like on Hugging Face, you have a whole lot of VITs or vision transformers, going from the initial VITs to the Swin to even the Coca we have today. So you could check out all these models which are available for you. And then you also have platforms like Zindi Africa. You have AI Crowd and Kaggle. So Kaggle with compute, Kaggle with data sets, and also Kaggle for competitions. Kaggle is really a go-to zone. You could check out this section on Papers with Code. There's this computer vision section. So look at all different computer vision problems which you could start solving today. So no single course contains everything. Don't focus on working from one course to another. Just focus on solving problems. And as you keep solving problems, you will keep getting experience. Follow AI researchers on Twitter, LinkedIn, or other social media platforms so you never miss out.